Welcome to yet another devlog for my still unnamed programming dungeon crawl management game. This week, I've been working on mechanics for the more complex programming challenges in the second and third section of the game, one of which I'll talk about in this video, and the rest I'll go over in future devlogs. In the second half of the video, I'll go over a Python AI that demonstrates using inter-agent communication to solve a tricky problem which no character can do alone. And then, at the end, there will be an exciting community announcement, so stick around for that. Or, just skip to the end if all you care about is exciting announcements. If you're new, this is a game that tries to capture the unreasonable excitement of writing a little simulation and watching the simulated agents live out their little simulated lives. But, as a game. The player controls a group of characters who explore the world and its dungeons collecting loot. Rather than focusing on manual control of each character or high-level management of pre-made AI characters, the game is about designing the behaviors of individual characters directly, using a visual programming environment, or, for the truly adventurous, a low-level WebAssembly API. The first big bump in complexity that the player will face is problems that require active communication and collaboration between agents. The first mechanic I've introduced to create that kind of problem is hauling objects which are too big to pick up, like these logs. The logs provide a haul action to any character standing adjacent to it, which allows that character to move the log one square in any direction. But it only works if the total strength of all characters who have used the haul action in the current turn is above a threshold. So one character isn't enough. At least two characters have to coordinate so that they stand next to the log and use the haul action together. So how do characters coordinate? If you've been following along in the comments, there was a conversation a couple of videos ago about the existing communication system, which was very limited. That's gone and has been replaced by a much more general system. Characters have a byte array, which they can write any data they want to, and it can be read back by any other character within line of sight. The visual programming system will build an easier to use communication system on top of that, but in the low-level API, there's just the bytes. It's up to the AI to interpret those bytes in a way that makes sense. In a second, I'll show one possible way of doing that. I'm deliberately making this communication channel totally open, so hostile characters can read the data as well as friendly ones. I think that will lead to interesting mechanics later on. For instance, you could have bee-like creatures in the world which communicate about food sources to each other, and the player could figure out how to interpret their protocol and use it to eavesdrop on their scouting of the level. Or, in competitive games, players would need to be careful not to use messages that the opponent could easily interpret. Or, alternatively, they could use well-known protocols for the sake of cooperative rather than competitive play in contexts where the game isn't zero-sum. Okay, so those are two new mechanics. Now let's talk about how an AI might go about interacting with them. In the last video, I showed some low-level code in Rust, but the main appeal of using WebAssembly for the AIs is that they can be implemented in a range of languages. So in this video, I'm going to use Python. Okay, so here's a Python AI, and if you watched my previous episode where I did an example in Rust, you'll recognize the basic structure here. There's a step function, which will be called by the game on every turn that the AI needs to take, and then the AI returns a command which instructs the game what action they want the character to take. And then within this function, the AI can query the game state and make any decisions that it needs to make, and also access its long-term memory. So this example is going to be significantly more complicated than what I wrote in the previous Rust example. So I've actually pre-written all the code, and I'm just going to talk through it, and then we'll watch it execute. But hopefully it'll give you a sense of what this looks like in another language. It's very similar. Like in the Rust version, I'm using auto-generated bindings for all of this, so I haven't written any custom bindings. And if I were to write custom bindings, I might change things a little bit, because some of these auto-generated bindings in the Python version don't come out being particularly idiomatic. They look a little strange. And so for a custom written version, I might do things slightly differently. So the final game may look a little bit different than this, but give you the sense. So I'm just going to go through in order. In previous comments, a couple of people have asked about the architecture of the AIs that the game will support, and like how you organize complex behavior. I'm not showing any kind of fancy architecture here. This is intended just to demonstrate the basic usage. So this is extremely linear. It's a very procedural program. It is actually sort of hitting the limits of the complexity I think that you can really support that way without it getting confusing. and you want to start adding some sort of architecture on top of that to make things easier to think about. But I'm not doing that. This is just very, very procedural code. The game will likely not make any assumptions about what kind of architecture you want when you're working at this low level. That will be up to you. Or if a user wants to write a library to support a particular type of architecture, then they could of course do that. The visual code will make more assumptions about how programs should be structured, but that's a different system. So in this low level, no particular architecture, you have to bring that structure yourself, and I'm mostly not doing it here. Like, I've just broken some stuff out into functions to make it a little bit clearer. Okay, so in order, the first thing we do is we load a byte array that the game supplies for us to use as long-term storage. So this just brings back a list of integers, and then we're gonna interpret that as a pickle store. If you're not familiar with Python, a pickle it's a very easy to use serialization structure that can store any arbitrary object. It's a little more convenient to work with than like JSON. So that's why I'm using it here. And so we unpickle it. If there was nothing stored, so this is like our first launch, or the memory store is corrupted for some reason, then we just initialize memory with some starting values. And those are going to be our current location in the world, and in the underlying API for the game, all locations are relative to the character's current location. So every time I query the game or get a notification something has happened, any locations are relative to my current location. So if I want to do a map that extends beyond the region that I can currently see by querying like the visible world functions, I need to keep track of where things are in some sort of absolute position. And so that's what this is. This is my absolute position, which I'm gonna move as I move through the world. So I start off at 0, 0, and I'm just gonna say that's my origin. And then passable tiles is a structure that's just going to contain a set of all the locations in the world that I know I can walk on. So all the tiles I've seen that I can walk through. So they're not walls, basically. And so the first thing I do after I have my memory every turn is I do this track location. So jump to that function. And what that does is it listens for notifications about interesting state changes in the game. And so these are anytime something happens in the world that the game thinks a character needs to know about, one of these notifications will happen, and I can pull them, the AI can pull them at the beginning of the turn to get a list of all these changes. And so relevant to what we were just talking about, one of those changes is a notification that the character has moved. So this might be because you requested to move in the previous turn. You said, I want to walk. And then the game is letting you know that you successfully walked. Or it could be that you were pushed, like there was knockback from an attack or something. So maybe you didn't voluntarily move, but you involuntarily moved. In either case, the game needs to let you know that's happened. And so we take that, and then we use that to modify our current location. So if we start at 0, 0, if we take a step, the game will notify us that we successfully took a step, and then we can use that to increment our position to keep track of where we are in the game. This other one is relevant to hauling objects around, which I'll come back to. So once we've updated our location data, we're going to take a look at the world around us in this build map function. And what this does is it asks the game to tell us about all of the tiles that we can currently see. And that comes back as a structure that has data about the tiles and the location of the tile that data describes. And again, that location is relative to the current location of the character. And so all I do is I transform that into absolute location based on what I know my current location is, because I've been tracking that. And then I check to see if that tile is passable. There's other data about the tiles, like what kind of tile it is, other things. But in this case, all I want to know is, can I walk there? And if I can, I add it to my list of tiles that I can walk, or my set of tiles that I can walk on. Otherwise, I ignore it because like I don't actually care about walls right now. And then the next step is we're going to do our behavior around hauling objects. So this is earlier I was talking about hauling logs around, and this is where the complex stuff there is going to happen. I'm going to come back to that. First, I want to do the setup that I'm using to do the communications that are necessary to support that action. So the first thing I do is I call a function called track items, and what that does is it looks around in the world for every item of a type I specify. So when I called it the first time, I'm saying track item, and we're going to track the log. These log objects in the world. And I built some keys into my memory dictionary for that. And then I look around in the world and I say, do I not already know about this thing? So is there already a reference to a log in my memory? If there is, I can skip this because I'm just going to do one at a time, or I'm just going to keep track of the first one I see for this example. And if I don't know about it already, is the item that I'm currently seeing, is it of that type? Is it a log? If it is, I'm going to, again, transform its location into absolute locations rather than relative. And this means that location will stay valid in my memory even if I move around because it's an absolute location. And then I'm going to keep track of when I saw this, right? So I can get a turn clock from the game that just tells me how many turns have passed since the beginning of the game. And then because I need tiebreakers in a second, I just add a small random value to that, a value between 0 and 1. So if I see the log, the first thing in the first turn, this will be 0 plus some small random float. And I store that in my memory. So now I have a record of if I have seen a log, where it is located, and when I saw it. All of that's in my memory. I do the same thing for the shrine, and the shrines are the little conversion centers where I can turn one resource into another type. And so what I'm going to try and do is haul the log to the shrine and then convert it into gold. That's the action I'm trying to take. And then I have this other function, negotiate consensus, which is my communication with other characters in the world. And what I want to do is I want to set it up so that all of the friendly characters nearby have the same information as me. So if I've seen a log, I want them to know where that log is. I want to tell them where the log is. And if I've seen a shrine that we can take the log to, I want to tell them where that shrine is. And then once we both know where those resources are, I want to cooperate with them to move the log to the shrine, because I can't move it by myself. I need at least one other character to help me. So I need to cooperate with them to move the log to the shrine and do the conversion. And so this is going to help me do that. So first I get a list of all the creatures I can see, because communication is always line of sight. And then I look at the data I have for that creature, and it has a broadcast field. And broadcast is a byte array, as I described earlier, a byte array that the character can write to and that I can read. So they've written whatever information they want to communicate to me here, and I'm going to do the same thing into my own broadcast and array in a second. And just for convenience, I'm treating this as a pickle store, because that's nice in Python, but you can use whatever you wanted. And then I'm going to, again, look for some values. And these are the same values that I just wrote to my memory in this function above, where I was looking in the one earlier where I was looking things up. This is the location of the log and the location of the shrine and the turn number where I saw those things. And I'm going to say, if I know about it, or we both know about it. So if I know where a log is, I'm sorry, if I don't know where a log is, or I do know where a log is, but they know where a log is that they saw earlier, um, I'm going to take their value. And this is just so that we can agree on which one we saw. It's, basically arbitrary. But I want to say, like, whoever saw the log earliest in the world gets precedence, and then that's the log we're going to use. And so here I'm just checking that. As I find between me and the person I'm talking to, who saw a log first, or the shrine, because I'm going to do it for both of these. And if they have the precedence, then I'm going to learn their value. And if I have precedence, I'm not going to learn their value, but they will learn my value when they do this same operation during their turn. And then I take the value that they're if I'm going to learn their value, I take the value they're transmitting and I convert it into my absolute coordinates. So it will be transmitted as the location of the log will be transmitted as a location relative to the other character's current location. I'm going to transform that into a value relative to my location by adding their relative location to it, and then adding my absolute location to that to turn it into an absolute location. And again, this is just so that when I move around, these values remain valid, right? And then I keep a record of what the earliest time that we saw this on, that we agreed on. Hopefully that's clear. So now I know where this object is if the other character knew where the object is and they learned about it before I did. And then once I've done that for all the characters, so everyone I can see, within those I've taken the earliest example of a log or the earliest example of a shrine, and I want to rebroadcast that for other characters to see. And I do that by, again, transforming the location into relative coordinates relative to me, and getting the time on which it was seen, writing that to the array that I'm going to broadcast to other characters. So now I'm all set up for that. And I do that for both the logs and the shrines. Hopefully that's clear. That's a little bit complicated, but at the end of this, once this is run for all characters in a particular turn, every character within line of sight should agree on which log we think is important based on who saw the log first, and which shrine we think is important based on who saw the shrine first. That's what this does. So that's our communication. There are many ways to handle communication problems like this. This is not necessarily the best one. It's certainly not the best one. It's probably not even the simplest one. I'm sure you can think of something simpler. There's much more optimal algorithms for coming to consensus about shared data like this. And hopefully I've made this clear. Like, this system is very flexible. You could implement whatever you wanted, right? You don't necessarily have to do what I've done. And in the final game, there might be some client libraries for doing this. So just like a default implementation of this kind of algorithm that you could choose to use, or you could write your own, like I've done here. I'm not sure how large this sort of the standard library will be in the final version, but there'll be something. Okay, so now once I've done all that negotiation, I know that I've made all the changes to my memory that I'm going to need to make, and I've made all the changes to this array that I'm going to broadcast, that I'm going to make. And so I just write those both back to the game. So I save my long-term memory because I'm done making changes. I save the array to broadcast because I'm done making changes. And then I have a possibly null command from this core function, which we're going to come back to. And if that's null, that means that, like, I don't have enough information to do the hauling step. Like, I don't know where a log is, or I don't know where a shrine is. And so I need to explore the world. And I'm doing the simplest possible exploration that you can. which is just a random walk. It's a very slow way of exploring the world, but you're guaranteed to see everything eventually, everything that's accessible. And so that's what this does. It's like if you can't do anything else, you just random walk, and that's how you use your turn, by returning this command. It says, I look up in my list of possible actions that I can take. I look up the action for walking, and then I pick a random direction, and then I tell the game that that's the action I want to take. I want to walk in a random direction. So that's my fallback. If I can't do anything else, I'll do that. But if I do have enough information, then I'm going to do this instead. So this is the meat of the AI. Well, I guess the communication part is probably actually the meat of the AI, but this is the part that actually affects the game directly. So here I'm checking that if I found a shrine and if I found a log, either because I saw it myself or because I learned it from another character during that negotiation phase, I'm ready to do this step. I have enough information. So now there's a couple of phases. Like first I have to get to the log, and I check to see if I am basically within a tile of where I know the log to be. If I'm larger than that, then I need to actually pathfind. I need to go to the log. And in that case, I will just pass in all the information that I know about the tiles in the world that I can move through, where I'm trying to go, where I currently am, into a standard A-star implementation. There's nothing fancy here. And I'm not going to show the code for the A-star because you can go look that up on Wikipedia or something. But that's the pathfinding tool I'm using. This is implemented in Python. It's just not very interesting. And then what that function will return is the next step in the path that I should take, which is, if you've done pathfinding before, this is a very inefficient way of doing this because I'm recalculating the entire path every turn unnecessarily. And so if you're trying to do this fast, you do some caching or something, but this is very naive. I'm just recalculating the entire path every time, taking the first step in that path, the next step I should take, and then taking it. And this is basically the same as the random walk, is I convert that step into location relative to my current location because that's what the game expects. Find the action that I can take that would be walking, and then take that action in the right direction. So that's very simple. So if I know where the log is, I will. If I'm not near the log and I know where the log is, I will walk towards it if there's a valid path. The next step is that if I'm close to the log and I look up in my list of possible actions that there's a convert action, and this is the convert one resource into another resource, that action, which is supplied by the shrines. And so only if I'm near a shrine do I have access to that action. And if I've gotten to this place, I know that I know that I'm near the log, and I have the convert action, so I'm near a shrine, which means I can convert the log into gold, which is what I'm trying to do. So I look up where I know the log is, do my location conversion into relative space, and then tell the game that I want to do this conversion action on the log, and then that will instruct the game to convert the log into gold. And at this point, I'm done. Like that's once I've hit this point, the AI has done all the useful stuff it's going to do. It's finished. For this example. And then the last thing is, if I don't have access to a conversion action, but I'm near the log, that means the log itself isn't close to the shrine. And so what I need to do is I need to move the log closer to the shrine. And this is the step that I can only do if I have help. At this point, I don't know that I have help, but it's very likely that I do, because of the way the AI works. So I just assume that there's someone around to help me, and we'll talk about in a second about how that works. So this is basically the same. Is I use the A-star pathfinding, but instead of trying to move to the shrine, instead of trying to move towards the log myself, I'm trying to find a path from the log to the shrine, figure out like what direction the log needs to move in order to do that. And that works in exactly the same way as my normal motion, except instead of walking, I'm using this haul action. Let's pretend like that's not there. That's not necessary. And I say haul in a particular direction, just the direction that the path told me to. And what will happen is, if there are other characters with the same AI in the world, we will have agreed on where the log is and where the shrine is through this communication step. I will have walked to the log. They will also have walked to the log. And then we will both be standing next to the log now. Or if I stand here long enough, the other AI will eventually wander by and it will also come to the log. And then we'll both be standing next to the log, and we will both use this haul action to haul the log towards the shrine. And with both of us doing it, we have sufficient strength to actually move the log. So those are my steps. As I communicate, then I go to the log, then I move the log to the shrine. Once we're at the shrine, I do this conversion, and that's all this AI does. And so if we go here, we can see that if I did those things successfully, I will have some command here. This will either be my command to move towards the log, or my command to do the conversion, or my command to do the hauling of the log, or it will be nothing. If it's nothing here, then I just do my random walk, and if it's anything else, then I do whatever it was, whatever the command was. So that's the entire structure of this. And there's, I think I've talked through all the interesting helper functions. There's a few more, like the pathfinding and stuff, but we're not going to talk about those. So that's this AI. And again, like, this is much more complicated than the other example, but still only a fragment of what you would need to do like really complex behavior. But you could sort of see that you probably want some additional structure on top of this to make all of this clear for real code. But for this example, this is good enough. And so here's the game running with two AIs that have the same script. And you can see they're both in the world. There's a log here and there's a shrine here. And so on the first turn, they will both see the log and the shrine and agree with each other about those two things. And so what we should see is we should see them both move towards the log, haul the log over to the shrine, and then convert it into gold. So if all works, that's what will happen in the next few turns. So let's just see if it goes. Okay. So because there's no step in the AI that actually tells them to walk over to the shrine if they're close enough, then it's actually broken, because they can't move the log any closer because it hits the shrine, but they're not close enough to do the conversion. So I'm going to cheat and move one of them over there. Come on. And they're going to fight because I keep running into him. And now he's close enough to the shrine to do the conversion. And if we take a turn, it converts to gold. So you can see that to make this really work, you'd need at least a little more there to do that last thing to make sure you're actually standing next to the shrine. But hopefully that at least gives you a sense of what a more complex AI might look like, this time in Python. I was a little bit worried when I started doing this that Python wasn't going to work very well in this environment, but this is actually really smooth. Like, everything hot loads quickly and well, and it all seems to run just fine. So I think Python is going to be a viable language for the primary scripting language that I encourage people to use if they don't want to write their code in Rust for the low-level stuff. I feel pretty good about that. So I think that's probably the decision. I was thinking it might be Lua or something, but I think Python's going to work. You could still use Lua if you wanted, but Python is the one I think I'm gonna support myself. So that is my example. All right, so here we are at the end of the video. So what's the announcement? People have asked several times about a Discord server, and I think it is time to do that. The Discord will be a place to talk about this game and other programming games related things. I'll also be sharing more frequent small updates and insights into my development process there. And also, it's where I'll be organizing playtesting. There's going to be some more on that soon. So if that sounds interesting to you, then you should join up. There'll be a link in the description. And that's it for this video. Thank you for watching, and I hope you will join me next time.